Welcome to part 1 of our 2-part tutorial series on buying and selling Raydium Pool token on the Solana blockchain. In this video, we'll focus on fetching and understanding liquidity pool information, which is essential for enabling token swaps. Liquidity pools form the backbone of decentralized trading, providing the necessary structure for buying and selling tokens. We'll cover how to connect to Solana, initialize a wallet, and query Raydium pools to gather details like token pairs, LP tokens, and vaults. Stay tuned for part 2, where we'll use this pool information to execute token trades. Let's dive in. This mermaid flowchart outlines what we'll be building. In the first part of this series, we'll focus on setting up the user wallet, selecting a token address, and finding a Raydium liquidity pool. User wallet setup. The wallet is created by decoding a private key in base58 format. The key must be 64 bytes long to generate a Solana key pair, which is used for signing transactions and interacting with the blockchain. This wallet is your tool for trading, managing tokens, and working with Solana. Choosing a token address. To trade, you need the token's public key on Solana. You can find this through official token sites, DEX platforms like dexscreener.com, or verified token lists. The address identifies the specific cryptocurrency you want to trade. Finding a Raydium liquidity pool. The script looks for a liquidity pool on Raydium for the token pair, example, your token and SOL address. Using the Raydium program ID, it finds the pool's address, token info, and market details. If a matching pool exists, it grabs the data needed for trades. Disclaimer: the information provided in this video is for educational purposes only and should not be considered as financial advice. I am not a financial advisor, and any decisions you make based on the information presented in this video are at your own risk. Please consult with a professional financial advisor before making any investment decisions. First, create a new folder for your project and open it in Visual Studio Code. Open the terminal in Visual Studio Code and initialize a new npm project. This will prepare your project to install the necessary dependencies. Now let's install the required packages for our project. Install at Raydium SDK. The Raydium SDK is a JavaScript library that lets you interact with the Raydium protocol on the Solana blockchain. It provides tools for working with Raydium's DeFi features, such as swaps, liquidity pools, and farms. Next, let's install at Solana/web3.js. This is the official JavaScript library for interacting with the Solana blockchain. It allows you to build Solana-based applications, manage accounts, send transactions, and interact with smart contracts. We also need to install BS58. The BS58 library is a utility for encoding and decoding base58 strings. This is commonly used in blockchain and cryptocurrency applications to represent binary data like Solana addresses and private keys in a compact format. Let's install .env. The .env library is used to load environment variables from an env file into process.env. This is essential for securely managing sensitive configuration data, such as API keys and secrets, without hard-coding them in your source code. And finally, let's install Express, a minimal and flexible Node.js web application framework. It's widely used for building web servers and APIs due to its simplicity and middleware support. First, let us create the .env file. In the file, initialize the wallet private key and the RPC URL. You can use the free Helios RPC or whatever you like. Next, we need to create a config.js file. This file will hold all the configuration settings for the application. We need to require the .env file to access the wallet and RPC information from the .env file we just created. This condition will check if the RPC URL and wallet private key are declared. The .env file must be defined with the wallet private key and RPC URL variables. If not defined, it will throw an error. Next, we need to define the config object with several important parameters. Basement. This is set to a Solana token address that represents wrapped Solana's native token. RPC URL pulls the RPC URL from environment variables. This is used to connect to a Solana node. Private key gets the wallet's private key from environment variables. This is used for transaction signing. Raydium_v4_program_ID contains the program ID for Raydium v4. This address is used to interact with Raydium's smart contracts. The module.exports equals config line makes this configuration object available to other files in the project that need to import it. Next, let's create a new file named raydiumpoolinfo.js. In this file, we will establish a connection to the RPC, initialize the wallet, and retrieve the pool market information for the requested token address. We will start by creating two functions, create connection and init wallet. The following dependencies will be required: bs58, configuration file details, and .env. We also need to import key pair, connection, and public key from web3.js. Let's start with the most basic piece, connecting to Solana. Here's our create connection function. This might look simple, but there's a lot happening here. We're creating a new connection object using our RPC URL. Think of this as our phone line to the Solana network. The confirmed parameter tells Solana how certain we want to be that our transactions are processed. It's a balance between speed and confidence. Next up is wallet initialization. This is crucial. It's how we identify ourselves to the network. Let's break this down. We're taking a base 58, encoded private key, and converting it into a format Solana can use. The length check is important. It helps us catch invalid keys before they cause problems. Let's test these functions to ensure there are no issues or errors. The create connection function looks good. Now, let's check init wallet. This looks good too. Great. Let's move on to the next step. Now we're getting to the exciting part. We need two more functions, get program accounts and find Raydium pool info. Get program accounts. This function acts like a search engine for Raydium pools. By providing two tokens, the base token and the quote token, it identifies the pool that facilitates trading between them. The filters we apply are akin to search criteria, targeting accounts that match the specific pool layout and include our token addresses. Here's where everything comes together, the Find Raydium Pool Info function. This is our main workhorse. This function serves as a lookup tool for finding information about a trading pool on Raydium, a decentralized exchange on Solana. When given two tokens, like SOL and USDC, it searches for the pool where these tokens can be traded and returns all the essential information about that pool. This includes the addresses where the tokens are stored, how many decimal places each token uses, and where trading orders are kept. Think of it like getting a detailed map of a specific trading venue. It tells you exactly where everything is located and how it's structured, which is crucial for anyone wanting to interact with that pool for trading or providing liquidity. Next, we need to make these functions accessible externally. To do this, we need to convert Find Raydium Pool Info, Create Connection, and Init Wallet into module exports. We will use another file to test these functions. Don't forget to export the following components from Raydium SDK: Liquidity State Layout v4, Market State Layout v3, and Market. Just a quick reminder, if you're enjoying this YouTube video, make sure to hit that subscribe button below. It really helps support the channel and allows me to bring you more great content. Don't forget to click the notification bell so you never miss an update. Also, I'll be sharing this code on my Patreon page. If you'd like to support me and gain access to more exclusive content, join using the link below. Let's create a new file to run the script and name it raydiumbicell.js. First, we need to import the functions we created earlier: Find Raydium Pool Info, Create Connection, and Init Wallet from the raydiumpoolinfo.js file. We also need to import the config file. What we have here is an async function called main that's wrapped in a try-catch block. because handling errors gracefully is always a good idea, right? Let's break it down step by step. Token to buy variable. This is where you'd specify the address of the token you want to buy. Right now, it's empty, but you'll replace it with your token's address. Creating a connection. Next, we create a connection to the Solana network by calling the create connection function that we imported earlier. Pool info. We call the find Raydium pool info function with the token to buy address, the base min address for the Solana Sol token, and the connection. This function returns the pool info. Error handling. If no pool is found, an error is thrown. Nobody likes errors, but it's better to know right away if something's wrong. Logging the result. If everything works, we log the pool information to the console. If something goes wrong, the catch block will handle it and log the error. Finally, at the bottom of the script, we call the main function to kick everything off. Now, let's run the script. First, we need a token address. Let's use the new Trump meme token that Donald Trump created. Simply put the token address into the token to buy variable and run the script. You will see all the token information retrieved for the specified token. While it may not make much sense initially, these details are necessary for the Raydium swap. I've updated the console log to display more relevant information. Token addresses and decimals are required for amount calculations. Vault addresses are needed for token transfers. Market information is used for price calculations and order placement. Authority addresses are necessary for signature verification. Version information ensures compatibility. Now, let's try another token, but this time, Pump Fund token. The server request warnings occur because we're using the free RPC version, which likely has a request limit. That's it for the first part of this tutorial. I hope you enjoyed it. The code will be available on my Patreon page. Thank you, and please stay tuned for part 2, where we'll use this code to perform an actual buy and sell.